Great, we should be live.
Okay, welcome to our weather discussion. I'm gonna turn off some lights, I think, just so.
Sure.
How's that? That's good. Right. So welcome to our weather discussion, Pete. Thanks for setting up as always. We've got a couple of interesting things to talk about, and otherwise, I think, relatively boring last several days of weather, not just here, but in a lot of places around the hemisphere. It just hasn't been that exciting. But there's a couple of things to talk about that of some interest. First, we have our last week's Pacific Coast, Northeast Pacific satellite movie. And one of the things that comes on at the end of this, I think it's, I don't know where we are in time, at 12Z on 30th. It's not quite, but it's a development that's going on here. You can see this cyclone developing and charging forward towards the coast of British Columbia. This is about the current time. I'm going to have a little bit to say about what's driving some of the weak cyclogenesis that's occurring here. You can even see elements of that resulting cyclogenesis in this picture. And then there's another one on the East Coast that has very different characteristics, both in its presentation, as it turns out, its underlying dynamics. And that's easy to demonstrate at a glance, but there might be more work that one can do. In fact, Brett, Michael, and I, and Patrick Beatty are working on some of those problems. So say just a word about that. But before I do that, I'll just, we'll start with an overview of our current weather. So let's go to our satellite movie over the continental U.S. if we could, Pete. So here's the visible for the continental United States. So let's go to the infrared. I think you get a little bit longer of the movie. This is too short. Thanks, Pete. Okay. Unsettled weather generally along the coast. Some interesting looking blossoming of convective clouds in the southern part of the Gulf of Mexico. And the entire cloud train goes all the way back to the eastern subtropics of the Pacific Ocean. So that's interesting, with a couple of different potentially wave perturbations within that flow. So that's interesting. This is the other storm. So the bookended storm that I wanted to draw your attention to, well to the southeast of Newfoundland. This is a nicely developed cyclone. It's not particularly deep. It's in the low 980s or something like that. So it's not really a monster storm, but we'll see some aspects of this event that it presents itself quite differently than the storm off the Pacific coast, which is more or less a linear feature along which there's some development. This is, of course, a closed circulation, and there's been historical development. I'm not sure if there's any more yet to come, but there's been historical development. So that's just a prelude to some of the elements of it that I want to talk about a little bit later. But broadly speaking, over the continental United States, this is, I think, mostly high cloud. I don't believe we see it in the reflectivity, and that's not surprising. It has a poleward origin, and it's coming down over the high terrain. And so some of the older cirrus that was maybe at the top radiating at such cold temperatures is just kind of fading away. There's a little bit of light precipitation or light higher cloud to our south and west. I think this is precipitating, so it's not impossible we see a snow flurry, but although the risk was also there on Wednesday and it never materialized. So I'm not sure that's a really good bet for the rest of the afternoon. The interesting weather around here comes around Tuesday next week. So that could be something of interest. Although I'd say moderate interest. But mostly the central part of the United States is high cloud free, but not low cloud free. As you can see, look at the low clouds, they're quite extensive in the light gray. And I was talking to Kate on her way over back from class. Maybe some of you know right off the top of your head. I don't remember the last day it was sunny around here. But it's just a faulty memory. I don't know, was it last weekend? Was there a sunny day on the weekend?
There's been sunny mornings.
Yeah, so we haven't really had a sunny day in quite some time. Not 3 weeks, but long enough to stop to notice. And yet we haven't had any really well-organized weather systems parading past us either. They've all been to the east, and some of them have skirted to the northeast. It's just been this low stratus cloud. And in many ways, it reminds me more of February, late February than late January. You know, this melting, you can hear it dripping off your house. It's never very cold, and it's cloudy. So it's got all those elements. Either that or January in Seattle, one of the two. So that's the picture over the eastern United States. Can we look at the western United States, Pete, and kind of divorce it from the week-long?
I can mention, I think I texted you, I was getting rain last night.
Yeah, and I had some too, but it was displaced in time from yours. I had it about 6:30. You had it probably about 8, right?
Yeah.
Yeah. So it was
But it was
funny.
27 out and raining.
Yeah, and then this morning there was a little bit of coat of ice on the windshield of the Volkswagen, which doesn't retain heat very well. And so it was a little bit of freezing rain or maybe frozen rain after it fell. I don't know which one it was.
Well, I can wait for you, John.
Oh, thanks, Pete. That's so nice of you. So here's our cloud street. Here's Hawaii. So keep in mind, this is coming all the way from the subtropics. And it will see in the analyses in a little bit of time, there's a cyclone right about this location. And you can see this is a linear cloud swath. There's not really much of a hint at all of a, closed or even semi-closed circulation. And there's some really interesting distinction that can be drawn dynamically there that you can actually see in some diagnostics, which is kind of fun. So keep in mind, we've got bookended weather systems on the coast at about the same latitude, 43 degrees or so north, one off the west coast and one almost equidistant off the east coast. So we'll take a look at those in a little bit of time. Can we take a look at the national radar next week? So here's our radar, and here's the unsettled weather in the southeast United States. A couple of spots with pretty decent reflectivity during the 50 to 55 PVZ range on the border of the Carolinas, and a little bit further south, some widespread, modest reflectivity, probably some moderate rain. We'll see when we look at the surface obs, and then some off the coast, southeast coast of, or southwest coast of Florida. And then here's the light precipitation. I don't know if it's rain and snow mixed in some locations. We'll have to judge by the surface temperatures, but I wouldn't be surprised. It doesn't look fuzzy the way that some of this reflectivity on the Ohio-Indiana border does earlier in the day. That might have been snow. And then here's the precipitation that's been, I think, fairly incessant for about a day and a half, maybe 2 full days up in the Pacific Northwest, particularly Puget Sound. On Wednesday, it was raining further south along the Oregon coast. Today, it's mostly in the Puget Sound and to the northeast of the Olympic range. So a place like Sequim probably has nothing happening there, but that's right up on the north part of the Olympic Peninsula. And this is part of that flow of cloud and moisture from low latitudes to the west. The rest of the country doesn't have unsettled weather, but it doesn't have nice weather either, as clearly demonstrated by what we've got going on outside our own weather.
I wanted to mention one other thing. In the Pacific, we were looking at this in our weather discussion yesterday. If you look at the visible out in the Pacific, I don't know, maybe the sun hasn't come up entirely there yet, but there's some spectacular open cellular convection.
To the north of that cloud band?
Yeah.
Yeah.
Well, what's so strange about it is it's covering much more of the Pacific than the closed cellular convection, which is a little unusual.
Yeah.
And the closed cellular convection is usually occurring under the subtropical high where it's warm aloft.
Mhm.
So I don't know what that means. It's just a little different than I'm used to seeing in the Pacific, where you normally have a lot of closed cells off the coast.
Yeah.
It's not much going on there like that. But
Yeah.
further up, there's a lot of open cells.
Yeah, south of the
So a
Aleutian
lot of
chain.
cold
and the
air
Bering Sea.
convection.
Yeah, a lot of cold air at that level, and that's one of the places where the variability of lower tropospheric cold air is highest, both at the end of the Pacific storm track and the end of the Atlantic storm track. So from day to day or from season to season at a certain time in the season, you can see huge variability. That's interesting. I didn't get a chance this morning to update my cold pool area, but there are certain places where if it's colder than normal in those, then the area gets larger over the whole hemisphere, because those are the places that are hot and then cold, and that might be one of them. So I don't know if that's the case today or not. I wish I had that time to do that. So it's an interesting observation. But now, off that observation, let's take a look first at the surface map, and then we'll go to the upper level charts, and we get a hemispheric, almost hemispheric view. We can see how cold it is off the Gulf of Alaska at 500. I'm going to guess right now it's colder than -30, given all that convection. So light snow, that's not Des Moines, right? Des Moines is kind of the center of the state. Maybe it is. I don't know. There's a light snow in central Iowa, then there's light
Cedar
snow.
Rapids.
Cedar Rapids, okay, then there's light snow at Council Bluffs, Omaha area. And that's part of that broken up convection, broken up radar reflectivity we saw over Iowa. There's even some light snow in Minneapolis and some across the border in Worthington. So a couple of places where it's snowing, but, and then south of us, looks like it could be a really good place to be for the next several days, Chicago and Rockford, light snow as well. And then some moderate rain as we saw some of that more intense echo across the the Carolina border, and then the border with South Carolina and Georgia as well. So higher terrain seemingly having a little bit higher precipitation rate, except the exception, Charleston, a pretty rainy day right there.
Another thing over us, on this picture, you can see the haze.
Yeah,
Haze over us.
widespread haze.
There's a lot of haze in the middle.
Yeah,
And it's wet haze.
Yeah.
It's reducing the visibility. It's not fog, it's just haze.
yeah.
Is that because of pollution? Or,
I don't know.
I mean,
we've
it's
been really
pollution
capped
is
last
affecting
year,
it.
so.
What's that?
I feel like we've been really capped. I mean, the boundary layers.
Yeah,
Well, it'd be fun to take a look at a Green Bay Sounding a little bit later. And we'll do
Yeah.
that.
we may be building up sulfates or something, and so as soon as we get to 80% relative humidity, we break down.
Yeah.
They say yes.
Yeah, that's interesting. Because that is a notable characteristic of the weather today. And I didn't notice on the reflectivity as well as I'm noticing it now in the obs, which is usually the other way around, but a band of light snow across southern Ohio and then into southeastern Indiana. That's where we saw that little bit of a fuzziness to the radar reflectivity. And it's a little bit further to the east where I thought it might be raining. These might be wet snowflakes though, because the temperature's 35 and 36 at these places. Maybe that's why the reflectivity's got a little bit more of a sheen to it than it often does in snow. But broadly speaking, for the last day of January, this is exceptionally warm. Everywhere. There's no place that's cold. In fact, we have somewhere on the, Zoe alerted me to this, there's a picture from last January 30th. Is somewhere on the desktop. January 30th, 1951 is the coldest day ever in Madison, minus 37 it got to that day. Last year on January 30th, we were about minus 26. And I was really sad about that. It looked like, because we saw this coming a week in advance, and it looked like no way we were gonna miss getting to minus 30. And I've never filled my lungs with minus 30 yet, and I wanted to do it. But we only got to minus 26, which I'd already done once before. So it wasn't that exciting to me. But nonetheless, think about the difference between yesterday or today and this. This is widespread, deep minus 20s, and right now the temperatures are all over 30 in that location. So it's at least 60 degrees warmer today than it was a year ago. There aren't many calendar days in the year where you can say that. Right? I mean, really, the all-time high for this date and the all-time minimum for this date might have the biggest range of the entire calendar year. But certainly you don't get all-time highs in July that are 15 degrees and then other all-time highs are 101. Or maybe 40, what would it have to be? 48 degrees and 108 or something? That doesn't happen. It just doesn't happen.
I think
So this is
in
the time of year.
a couple, this week in Denver, I think it was in Denver, I saw that they had temperatures near 70.
Is that right?
Yeah, it was in the 60s at least, but
That looks like it's going to be the case this weekend in Rapid City, the Banana Belt of South Dakota, places like that. It's going to be really warm, exceptionally warm. They're going to not believe it. So it'll be so warm their heads will spin. That's to coin a phrase, right? Let's go. So thanks for going here, Pete. We had just done the surface map. We haven't done the upper level chart. Let's do that next. So let's take a look at the super pizza courses. No option there. It's not a 500 millibar. So this
Seriously, it was working earlier.
it might be have to be an option.
All right, we'll use
Okay,
the
so
name.
and this is from which analysis? This is from
This
the
is from the NAM.
analysis.
Yep.
Okay, so here's our 500 millibar map from this morning at 7 a.m. Broad zonal flow with a little bit of a perturbation. Here's where we saw that cloudiness coming around the ridge in the satellite picture. It's all high clouds. It's probably not being forced to rise anymore. In fact, that's maybe why it's kind of decaying in terms of the satellite temperatures. Here's a really nice upper baroclinic zone, and it's in a region of cyclonic shear, so maybe there's some broad subsidence there. I think that might even be that dry spot we saw in the Water Vapor movie. But it's a really broad upper trough, and so one doesn't expect a small scale kind of intense cyclogenesis going on here, just broad lifting. And as I said, I'll say more about that as we get further into the discussion. Broad northerly flow without much baroclinicity, that makes it boring in my estimation. That's too bad. It's 16 here at Flagstaff, and it's minus 26 at Amarillo, so it's only 10 degrees over the Gadsden Purchase or something. That's not a large temperature contrast. And not really strong winds, 75-ish knots, a couple of places, but not really a strong upper jet either, at least not at 500 millibars. And then a broad trough over the central part of the United States, the asset region being in the eastern part of the United States. But again, it's flabby, it's not well organized, but the asset maximum ought to be right about here, Georgia, Alabama, Panhandle, Florida. And that's about where we saw the more intense reflectivity over that part of the country. So, and moisture perhaps provided by flow from further to the south and west. So there's a nice couple of relationships there. Here is the upper wave associated with the storm I hope you paid attention to off the coast of Newfoundland. This is a little bit smaller scale wave. The map projection is a little bit funny compared to what we're seeing right in our own central longitude, but nonetheless, This is a small scale wave. It's got a little bit more variability to it, but certainly the curvature is more intense than it is over this broad scale wave. And certainly the curvature of that is more intense than this broad, weakly curved flow. So that's something to keep in mind as we go a little further into the diagnosis. Let's go to 300 millivolts briefly. I'm struck by the lack of variability at 500 millivolts on the last day of January. There's just none there. Here's a subtropical jet, most we'll see in a minute, at 107 knots. And then this might be the axis of a polar jet, I don't know, with a subtropical axis further to the south. We'll see in just a second. Here is a really stronger jet, 150-ish knots, 172 is the maximum in here in the central part of Saskatchewan, or Alberta, sorry. And that's a really strong upper jet, strongly curved. And then the curvature is quite intense as it rounds clockwise down towards Arizona and New Mexico. So broad subsidence most likely occurring in this region. And then broad, but not particularly focused descent, as I mentioned before, in that location, not aided very much by jet entrance or exit regions. You have to have a long flow gradient of the wind speed for that to be a serious contribution, and that's just not the case here. It's much stronger in a place like this, where you go from 170 to something like 70 or 100 in a short distance.
One thing you can't see on here is the polar night jet, and it's very far forward. It's hardly in this hemisphere at all. It's and maybe that's what they were looking at sun stratosphere warming. But the polar night jet is shifted so that these jets are not interacting with it at all right here.
They don't seem to be interacting with each other at all either, for the whole winter, I would say. That seems to have been the case. In fact, let's go to 200 and just for a moment and see what goes on, especially over Florida, the higher you go. Well, actually, then that's a pretty deep jet, but it's stronger, as you can see, at 200 millivolts. So the core of the jet, this is all subtropical. There's nothing at all polar about this one down across Florida. And then you can see the connection across the rest of the Eastern Pacific. The feature that was kind of digging southward into the Four Corners area is definitely a polar jet. It gets weaker the higher you go. This thing is about a deep tropospheric structure, all the way from the bottom of the polar tropopause up to maybe the tropical tropopause.
So I suspect about 4 or 5 days ago, that was a subtropical jet.
Yeah, so that's probably the case.
It's an aged subtropical jet.
And then you have the connection on the satellite way down to Hawaii where the cloud stream's coming from. So it's all kind of consistent with that.
Go up a little higher if you can. Can you go up to
We can go to
20 millibars or 10 millibars?
I don't have the analyses.
We have
for
100
those.
though.
You might go, yeah, you can't see the polar night jet yet. It's up higher.
But you can see a stronger gradient around the pole.
Yeah,
Geopotential height. So there's some semblance of it there, and then weaker everywhere else.
But there is a significant
You look at
interaction
latitude surface.
with the polar night jet in Asia.
Mhm.
That the subtropical jets are reaching up to the polar night jet over Asia, and then there's a continuous interaction from stratosphere down into the troposphere.
Mm.
And that may be affecting things. If it does anything this year, it looks like it would create the polar vortex that we like, if we want it really cold, over Asia.
Mm.
And so it might be Siberia that gets hit with it this year.
They can have. We're already too far into this. This is an unsalvageable winter as far as I'm concerned. It's over. I just assume we get to spring training in a couple of weeks anyway. So let's now, the last thing I want to do is go to my vertical motion page.
Do you have it up?
I had it on one of, I think it might be the first of those. So let's take a look at the 12-hour forecast. This is from last night, so it's valid this morning on vertical motion at 700 millivolts. This is a quasi-geostrophic vertical motion. So here's the couplet. Yellow is ascending every decipascal per second, so it's something like 1, 2, 3, 4, something like 10 centimeter per second updraft. This is about an 8 meter per second downdraft. Here's the storm, different map projection than we've seen before, to the southeast of Newfoundland at 12Z this morning. So it's corresponding to what we saw on the satellite as well as on the upper level charts. Really nice couplet of ascent and descent, sort of the yin and yang, right, which is characteristic of these nice developments. So here's the cloud head, here's the subsidence back behind, and you can see both of those elements in the satellite picture. At the same time, at 700 millibars, you see, I should mention, these dashed with dotted white lines are the 500 to 900 millibar thickness. So they give you a representation of the average column temperature in the lower troposphere. And so in this storm, you get a really nice comma-shaped thermal structure, which is characteristic of a nicely developed cyclone. Here is the ascent region, almost about the same intensity, slightly different geometry, and then the descent region up sheer of it, that is off the Pacific coast. So this is associated with that weak disturbance that's trying to get itself organized. Notice that they're not really a yin and yang, they're more aligned along the shear line. This is kind of wrapping the whole thing up, so they're different, they look different just at a glance, and everything else in between I don't care about today. So let's take a look at some other partitions of this. This is the total quasi-dystrophic vertical motion. And you can look at the part that is forced by the along isotrope Q vector, so the Q vector part that's only parallel to these thickness lines, for instance. Almost no difference between the total and just the shear-wise, so-called shear-wise part in the western storm. And there's some difference between the total and this shear-wise part that's associated with our Atlantic storm. And you can see what that difference is by going to the rest of the piece, which is the so-called transverse part of the Q vector, and then we solve from its convergence for the vertical motion. So this is the part that's related to Q that cuts across the isotopes, whether from cold to warm, which is chronogenetic, or warm to cold, which is chronolytic. And the convention for the ascent and descent is the same. So substantially less ascent from that portion of the Q vector in the eastern storm, and it does seem to have a band along sort of the frontal boundaries, and that's consistent with it being more like a frontal vertical motion diagnostic. And then over on the west coast storm, totally different types of structures. This is a more intense and quite linear band of chronogenetic lifting, is really what it is. So it's a totally different types of storms. Let's go to three other partitions. We first start with the Sutcliffe piece, which is right here. So this is the part of the vertical motion that comes from the simple assumption about the forcing for the vertical motion. And that is you can reduce the entire either Q vector form or traditional form of the Omega equation, according to some assumptions, to just positive or negative vorticity advection by the thermal wind. The thermal wind is parallel to all these thickness lines. So this must mean that there must be a vortex right about this location, because down shear of that spot there's large PVA and that produces ascent. Up shear of it there's large NVA and that produces descent. So this is the vorticity advection part of the vertical motion forcing. And if we were to go back, I won't force us to do it, but if you're going to go back to the total, you find out that this is the largest part of the total vertical motion. The piece that's not included in here is small and usually works in the opposing direction. Now, if we split this vorticity piece into the two types of vorticity, shear or curvature, it gets to be really interesting. So here's the shear vorticity asset. Look at this. Just shear vorticity does almost nothing for the eastern storm, but it looks like it does just about everything for the western storm. And let's go to the curvature vorticity piece. These two sum to the total Sutcliffe that we just saw. In the curvature piece, it does the whole story in the eastern storm, and it does, journeyman work for the western storm, but not quite the same intensity as the curvature piece. So, the shear piece. So it strikes me that in every individual storm, there's going to be a different partition between these two types of vorticity advection and driving of vertical motions, and you can use that information to actually make statements diagnostically about what's the role of the shear vorticity in this low-level development. What's the role of the curvature vorticity advection in the low-level development? And part of what we're doing, Michael, Brett, myself, and Patrick Beatty, is trying to actually unravel some of these questions for a series of storms that we are trying to manufacture optimal initial conditions to determine, make them either stronger or weaker, and see how some of these signals change when we do that. So it's just a really nice example of two storms. They don't look the same on a satellite. Sometimes they do look the same, and they have this hidden diagnostic difference. But even at all appearances being different, it turns out there's a diagnostic reason, at least underlying what some of those differences are, which is kind of interesting. And it's something you can look at every day if you just kind of pay attention to it. So that was my search for something exciting in the midst of the gloom. I hope that it got you somewhere. So. And then Zoe was going to give us our discussion of the forecast today in the absence of Morgan. Originally, she said, I'd like to be Michael Morgan for this week. And I said, no, you never want to say that. You might want to substitute for it. I think that's probably a better way to say it.
Yeah, not like.
Oh, okay. Well, I think being him is being like him. But anyway, you're a perfect person to do it. So thanks.
Give a quick shout out. We got a couple of alumni that said hi on the stream. Ari Sarsolari says he just gave a weather briefing to his colleagues. He still uses the lessons from the master, Professor Martin. He said he was about to say here, and he heard in his voice, your voice in his head saying, where? And then Jonathan Urban also says on Wisconsin, he's enjoying the briefing. So welcome, everybody.
All right.
Ari still has a job in spite of that, that's.
Nice.
Yeah, so I don't have too much today, but yeah, pivotal, we can just kind of step through some of the current future, weather in the next few days. See the, unorganized convection and weather down in the southeast of the US and, high over the, Rockies and some of the evidence of that plume of moisture coming in the northeast. So something to look at that Michael had noted last week was a development of a latitude cyclone that comes up the east coast. Kind of models have now congealed on a forecast that's on the milder side. And we'll see that Wisconsin kind of stays cold and dry for the next week or so. So we jump to 18 hours and see that relatively quickly this surface feature has started to develop, hugging the east coast. And yeah, some precipitation around that. We can go up, look at some of the upper features, air dynamics, 500 vorticity. So we can see that there's a nice trough associated with this feature, and downstream of it is where the surface feature is located. Nice little shortwave feature embedded within that might be driving some of the development at this time. We jump another 12 hours in the forecast. Still intense trough. And if we jump down to the surface, again, see that development has continued.
You should, and this time here, this is one you should look back at the earlier fog.
Oh, yeah, that's right. That was the one that was 9:51.
Yeah, I think it was at this time.
Yeah, so we can go look at that. Let's go all the way to Sunday or Monday at 0Z because we'll switch times. So from Monday forecast, it had kind of congealed on this answer, but yeah, if you could get back to Friday's forecast,
Yeah,
you can't.
Yeah, that would have been fun.
But there are still some solutions in here that, 94, 92, the positioning.
Yeah, that's
And
a
all kind of-
megalopolitan snowstorm. That goes all the way from effectively Washington DC to Boston. Portland's the only city spared around it. That's amazing. Totally different.
So what happened? What were they picking up on that wasn't actually there?
I think the ridge is too strong in the west. I think it just flattened out everything downstream. That's my guess, but that's just a guess.
Yeah. Awesome. Yeah, so it started to just bounce around the low thousands and staying off the coast for most of the more recent runs. If we jump ahead another to say 32 hours, we see that now off page. We can go back to the 30 hours. You can see that it does deepen down to 996. So it's a little bit more intense, and if we jump back up to the 500 millibar vorticity. You can see nicely downstream of this trough that's going to help force some of that, good for some of that ascent. The reduction. Something to note. So, yeah. If we go back to the surface, things to note, kind of future Wisconsin stays pretty cool, warms up a little bit, and dry. Then if we go forward to 48 hours, something kind of to know in context of, sorry. Yeah, so there's a storm that goes right ahead of us, doesn't look like any precipitation associated with that mid-latitude cyclone. It's gonna reach down Wisconsin, stay dry. Fortunately, if we go forward,
Well, can we stop here a second?
Yeah.
I don't think we've seen 550 decremeter thicknesses all winter long. I think, I mean, it hasn't been warm, it's just not been very cold. This might be the warmest day of the winter so far. What does the 2-meter temperature say at this time? Wow, how's it staying there? It's 12, oh, it's 12Z, how about 18Z? Let's go to 18Z.
Yeah, we do have some snow to melt too.
Yeah, I guess that's it,
Yeah.
that's entirely the answer.
I mean, it's gonna get foggy.
It's gonna be foggy, for sure, because it's consistent warm advection for 18 straight hours leading to that time, with snow on the ground. How is the snow on the ground? That's what I,
Yeah.
it hasn't been that cold, just hasn't been warm enough, I guess.
Well, the difference between, I mean, in Colorado, it's gone right away, right?
Yeah.
And I think the major difference is humidity. For one thing, humidity keeps it from going very fast, but also wind.
Yeah.
And we just don't have that
We've been windless.
dry wind humidity.
Yeah, that's a good point. Just eats the snow away. doesn't it?
yeah, we
Yeah,
can look at snow depth, and snow and
So for this kind of warm advection and this kind of 850
Yeah,
temperature,
find the-
we are
find the
not
cold
getting
air.
what we deserve. We're gonna have a tremendous stable day. You can bounce a basketball in a stable day on Sunday. Probably better than that.
It's right where the cold air is when it snows. Cold air.
yeah. So there's not too much interesting that happens. Mid-latitude cyclone kind of falls in the lee of the Rockies, but doesn't really progress eastward if we look ahead 12 hours, sure, and we see that it kind of stays in kind of Kansas, Nebraska area, and if we go another 12 hours, we
What
see
about
that
that snow? Is that upslope snow in Wyoming and parts of Utah? Is that what it
Looks like
is?
it.
Yeah.
Okay. Seems like it's got a weird orientation to the nature of the distribution of the sea level pressure, so like, not one I'm familiar with at a glance. Yeah, okay, sorry.
That's fine. Something, yeah, as we look, now we're at 18Z on Monday, something good for things to note for those who follow politics. Iowa caucus happens around that time. So it should be nicer weather for Iowa, so, that might not stop as many people from going out and taking part in the Iowa caucus.
When does the locust plague descend on Washington DC? Because it's certainly, I mean, something like that ought to happen. I don't see that in the forecast yet.
That's not in the GFS.
Okay,
And yeah, so they're working on that
okay,
parameterization.
yeah, the locust parameterization. Toads?
You can see with Iowa caucus, how sensitive Washington.
How much,
That's pretty good weather though.
how much snow they used to get in Colorado? They say that low there and it dropped and now it's left over upslope. How much do they getting there?
Not much in Colorado.
Weird, isn't it? Nothing. It's all-
Lot of-
Wyoming's got it.
Yeah.
Wow. It could be raining.
Yeah.
Early February.
In all the years I lived there, I've never seen rain in February or
Not
January.
much precip at all, really.
Nothing? Okay.
It's all west of them. I mean, I guess that's kind of where it was, though. It was on the west side of that low.
But then it drops south.
Not really.
Does it? Oh, it just heads out?
Colorado is here. So
Oh.
it's
Yeah.
a
Well,
little bit.
this system redevelops a little bit as we step forward another 12 hours. You can see that there's something, we might get a little bit of light snow showers associated with this low disturbance that goes through, but relatively dry forecast. Skip.
Can I ask if the 060 forecast looked the same here? Because I think I saw that before I went to class today. It looked like Tuesday was a little more interesting. Yeah, okay, it is a little more interesting.
Okay,
yeah. But yeah, the newest one is less interesting. Interesting.
yeah,
Too bad.
so I could always jump back,
I know, but even when we're scrounging for the scraps at the king's table, we can't do that.
but we could look at maybe LZ from find the day.
You're finding one to
Right.
believe it.
So that's a little bit closer.
Yeah, it looked more like a Chicago event earlier this week, and then it kind of crept, this is
Yeah.
good. And then it crept a little northward, but even so, we're talking about a 2-inch accumulation, maybe over 18 hours. But at least it would look like winter.
Yeah,
It's kind of like winter now. Except in my yard, the snow's all yellow.
But you got a K down the
yeah, so it should be a relatively warm for this time of the year, next weekend, and dry. Maybe expecting something to pop up Tuesday, but there's nothing too spectacular for us.
Do we see the sun? Weather Service has been saying sun on Sunday in 40s.
fog in 40s. I don't see how it's gonna be sunny. I mean, that was kind of one of the things that I was
Yeah.
interested in seeing was
Can we-
exactly that. To see the temperatures at in the 30s or 40. If the sun comes out, it'll be that warm, but I don't see how it's gonna do it.
Mostly sunny, high mid-40s.
Wow.
What do they know that we don't?
Can we look at
A lot,
the
but I don't know
sun?
particularly what it might
We
be.
could do that either within, if we go back to like either Sunday or now. That was one of the things we're gonna see why we get.
So this would be
Yeah.
18Z.
The snowpack is pretty deep.
Yeah, it is.
I got nearly a foot.
Yeah.
Yeah, there's still a lot of snow out there, as my dog likes to play in.
Mhm.
But yeah, so
I don't know how we're not gonna get fog with the sublimation going on at 37 degrees.
yeah,
I don't know if we get some wind to mix it out.
Yeah, there's that. That's not, I don't know. I'd love it to be sunny on Sunday. But I was thinking that when I came in, but I was discouraged by what we saw together, so I don't know.
yeah. So maybe Sunday. But
And no cold air in the long range? I don't think so, right?
no, if we look at, you know, we see this one, 200.
Yeah, 5'10" thickness, that's not terrible. It's not really warm, but it's not terrible.
Well, why don't you just for the heck of it, look at Siberia and see how cold that is?
Yeah, let's do that.
So yeah, continental.
No, they don't have them. I'm not really funny about
It's gonna,
498, middling.
it. Some-
It's better than here. I'm not saying it isn't, but it's not.
I don't think it's incredible for there. I mean, it's good.
This is
460 is still bad.
Look at the 2 meter temperature. Yeah, see what that is.
Oh, you're in the -20, that's pretty good.
yeah.
That's pretty good.
But what is it at 850? Can you look at,
Yeah, the upper air, the top one.
how cold is it there?
Oh, that's just where the temperature is
oh, I'm
down.
sorry.
-20-ish, 15, 20 something.
So it's warmer at 850.
Yeah.
So that air is not being wafted, that air is still sitting on the ground.
Yeah, it's a deep boundary layer. Deep polar boundary layer. What an interesting thing.
Take a sounding over here and see it.
And it's not really that anomalous.
Yeah.
Oh, widespread, the anomaly's not so widespread.
I think that's part of the problem. The air and poles are just sitting on the ground.
Yeah.
Cold air.
Rats. I think that's it. This is the 16th of February, right? So that's it.
Yeah, so winter is coming to a close.
Yeah.
Stay tuned for spring.
Eskimos are coming out of their huts. Their igloos.
Yeah, that's about all I've got. Unless anyone else wants to look at something. There's a groundhog next week, right?
That's right. It's on Sunday, right? Yeah, so the groundhog.
Well, if
Oh,
it's
is that what
foggy,
we're
you won't see
looking
Yeah, that's right.
Don't drive angry.
All right.
Well, thank you, Zoe.
Thanks,
for all
Zoe.
Thank you, Pete.
Thanks.
Oh, definitely more.
Yeah. I didn't have that much time. Here, I need to get used to the fact that I like it.
But there is some interesting things going on.